Hello. In part 3 of peripheral nervous system, I have explained about just a small introduction about the autonomic nervous system. I have shown the differences between the parasympathetic and sympathetic in this session. I have also showed the locations of various ganglions of these parasympathetic and sympathetic nerves. If you have any queries, please feel free to write to me, and let's start with the session now. Coming to autonomic nervous system, in this topic, the objective we will learn is compare between the somatic and autonomic nervous systems, describe the anatomy of autonomic nervous systems, discuss the physiological properties of autonomic nervous systems, and comprehend selected homeostatic imbalance of the autonomic nervous system. This is what we will look into. These are the objectives we will look into it. Okay. So the autonomic nervous system consists of motor neurons that innervate smooth and cardiac muscles in the glands. Okay. So from the word autonomous means free functioning. So you have to understand that whichever organs that is freely functioning in your body without your control are innervated by autonomic nervous system. This is a simple thing you have to understand. Okay. So it operates at the subconscious control, and it innervates the visceral organs. Okay. Coming to the overview of autonomic nervous system, the autonomic nervous system differs from somatic nervous system in case of effectors, efferent pathways, and the target organ response. Okay. So in effectors, the effectors of somatic nervous systems are skeletal muscles. Okay, this somatic nervous system, they act on the voluntary skeletal muscles, whereas the autonomic nervous system, they are controlling the cardiac muscles, smooth muscles, and the glands in the body. Okay, then as far as pathway is concerned, the somatic nervous system neurons are highly myelinated. Okay, the axons of the somatic nervous systems are having good myelin sheaths, whereas the autonomic nervous system axons are having less myelin sheath or no myelin sheath. Okay, so there are ganglions. I will show you. There are preganglionic fibers as well as there are postganglionic fibers. I will show you with the model. So the target organs in the autonomic nervous systems are the glands and all the visceral organs. When you take it, the target organs, it is acting on the visceral organs. Okay, and there are different types of neurotransmitters released in the autonomic nervous system. We will discuss the main neurotransmitters in somatic nervous system is acetylcholine, whereas there are different neurotransmitter substances with working with the autonomic nervous system. So comparing to these pictures, so these are the neurons that is common for both autonomic nervous system as well as somatic system. The somatic nervous system axons are heavily myelinated, whereas the axons of the autonomic nervous systems are slightly myelinated, or the myelin sheath is completely absent, or the myelin sheath is completely absent. So these somatic nervous system, that's the peripheral nerves that we discussed before, are acting on the skeletal muscles. There are 600 skeletal muscles. Okay, whereas these autonomic nervous system fibers are acting on the visceral organs like intestine, stomach, then the glands, cardiac muscles, etc., etc., etc. So autonomic nervous system itself, we divide it into sympathetic and parasympathetic. Okay, we divide it into sympathetic and parasympathetic. So now what we will do is, I'll show you two pictures to explain about the sympathetic innervation and the parasympathetic innervation. Okay, so in this picture, what you see here is, this is the parasympathetic nerves, the third cranial nerve, seventh cranial nerve, ninth cranial nerve, and 10th cranial nerve. Okay, 3, 7, 9, 10. Oculomotor, facial, glossopharyngeal, and the vagus. Okay, and sacral 2, 3, 4 nerves are parasympathetic nerves. Okay, okay. Now, if you look at the sympathetic nerves, these nerves are derived from the ganglions of the thoracolumbar nerves. I will show you all these ganglions in the model, and you can see different places. Okay, so now one thing you have to understand in common is whatever organs that is supplied by the parasympathetic nerves also supplied by the sympathetic nerves. Also supplied by the sympathetic nerves. I will compare and show you. What you see here is the parasympathetic nerve distribution. The parasympathetic nerve distribution. If you see here, this third, seventh, ninth, and 10th cranial nerve and sacral 2, 3, 4 nerves are parasympathetic nerves. The third cranial nerve is forming the ciliary ganglion in the oculomotor nerve. The seventh cranial nerve is forming the pterygopalatine ganglion of the facial nerve. Then the ninth cranial nerve is forming the otic ganglion of the glossopharyngeal nerve, and the 10th cranial nerve is directly distributing the fibers to the heart, bronchus, trachea, stomach, liver, pancreas, intestine, large intestine. Then sacral 2, 3, 4 nerves are innervating the bladder and the ovary and the testis regions. Okay, so now what you have to understand here is this is the nerves. What you see here, the parasympathetic nerves. So the parasympathetic nerve is innervating the pupil of the eye, salivary glands, the lacrimal glands in the eye, salivary glands, submandibular, parotid, and sublingual, then the heart, trachea, bronchus, stomach, liver, pancreas, small intestine, large intestine, bladder, and the reproductive glands. Same organs are also innervated by these sympathetic nerves. Okay, so what you see here is this sympathetic nerves are derived from the thoracolumbar outflow. I will show you the sympathetic ganglion. So what happens here? From the nerve, from these respective thoracic and lumbar nerves, the preganglionic fibers comes out and forms a ganglion here. From this ganglion, these branches goes to the iris, salivary glands, then the blood vessels, heart, trachea, stomach, liver, kidney, then glands, all this. Okay. So if you look at the anatomy of here, this is thoracic 1 nerve that is going to the iris muscle of the sympathetic ganglion. Okay, so what I told you, the parasympathetic nerve is also innervating the iris, and the sympathetic nerve is also innervating the iris. Okay, so the parasympathetic nerve will constrict the pupil. Okay, for example, when you are looking at the far image, parasympathetic nerve, that's the oculomotor nerve, is constricting the pupil, whereas the sympathetic nerve is dilating the pupil. You see, whatever action done by sympathetic, the opposite action is done by the parasympathetic. This is what you have to understand. Okay. Likewise, the sympathetics will decrease the salivary gland secretion, whereas the parasympathetic will increase the salivary gland secretion. Parasympathetic will increase the salivary gland secretion. Okay. Next, the heart rate is reduced by the parasympathetic stimulation. Okay, whereas the heart rate is increased by the sympathetic stimulation. The rate of contraction is increased. Okay, I'll tell you one example. You are standing in a running track and you hear the starting signal, immediately the sympathetic stimulation will excite with the sound and the heart will start to beat fast. Suppose if you see a scorpion in your hand, suddenly you out of fear you start to run away because at that time you feel your heart rate it is increasing fast. That is the sympathetic nerve is excited. Okay, and for example in the trachea and bronchus, sympathetic innervation causes dilatation, bronchodilation. It causes the bronchodilation. So generally for pharmacology students this is very important. For example, the parasympathetic nerve will do bronchoconstriction, whereas sympathetic nerve will do bronchodilation. Okay, so what is asthma? Asthma is a constriction of the bronchus and the bronchioles. Okay, that leads to difficulty in breathing. So we give a puff, okay, bronchodilator like salbutamol or terbutaline. So aminophylline, all these are the bronchodilator drugs. That means what? They are acting on the sympathetic nervous system and they dilate the bronchus, but they also increase the heartbeat. They also increase the heartbeat. That's why patient, when they take the puff, bronchodilator medicine, and they feel the heart is palpating. That is due to sympathetic effect. We are giving the medicine to stimulate the sympathetic nervous system and do the bronchodilation, but heart will start to increase. Okay, likewise there is a superior celiac ganglion that is formed from the T5 to T11. Okay, the celiac ganglion it supplies the foregut of the digestive tract, that is up to the second part of the duodenum, and also it is supplying the liver, spleen, adrenal gland, and also parts of large intestine. Whereas the parasympathetic, this vagus nerve is supplying the heart, bronchus, stomach, liver, small intestine, all this stuff. Okay. So as I told you, the vagus nerve, the 10th cranial nerve, is the longest of all cranial nerves. Okay. Likewise, the celiac ganglion centric intestine, and T12 123 L123 ganglion forms the ganglion, inferior mesenteric ganglion. It supplies the gonads, bladder, kidney, and all this one. Okay, so you can see the summary of functions. The sympathetic will dilate the pupil, reduce the salivary gland secretion, reduce the oral secretion, do vasodilatation of the blood vessels, increase the heartbeat, and dilate the bronchus, reduces the peristaltic movements, then increases the peristaltic waves. Okay, then urine secretion will be decreased by the kidney, and the smooth muscle will get relaxed of the bladder, and the male and female increase glandular secretion. So during the time of sex, the ejaculation is caused by the sympathetic excitation of the inferior mesenteric ganglion, whereas the opposite function is done by this parasympathetic. Okay, like like it causes erection for the male, then it contracts the smooth muscle of the bladder, then increases the peristaltic movements, then causes bronchoconstrictions, decreasing the heartbeat, increase the salivary secretion, constrict the pupil. So this is the difference between parasympathetic and the sympathetic innervation. Okay, both this parasympathetic and sympathetic are coming under the umbrella of autonomic nervous system. This whole autonomic nervous system is coming under the umbrella of peripheral nervous system. Okay, so These other receptors, all these other stuffs we will discuss with the deeper aspects of physiology. Okay, so this is what you have to, the basic things you have to know about the parasympathetic nerves. But I would like to show you, the ganglions. Yes, coming to the ganglions of the sympathetic and parasympathetic, as I told you, these parasympathetics are derived from the thoracolumbar outflow region. Okay, so these are the ganglions. If you look closely of this ganglion, this is a fourth thoracic nerve. Okay, so there is one, the fourth thoracic nerve, and there is another ramus coming, white rami, that is coming from the fourth thoracic nerve. So this is the gray rami and this is the white rami. Both comes and forms the ganglion. This is a sympathetic ganglion. This ganglion is present in all the areas of the adjacent vertebrae. Okay, so if you see here, adjacent to the vertebrae, these ganglions are present. These ganglions are present adjacent to the vertebrae. So these ganglions are interconnected. These ganglions are interconnected. Okay, so if you see here, these ganglions are interconnected. Okay, so now if you see, these ganglions are interconnected. All these are the sympathetic ganglions that is present adjacent to the vertebral body. Okay, so for example, I will remove this sternum. Okay, now if you see this, if you see here, this is a sympathetic ganglion, this is a sympathetic ganglion, and this is the intersympathetic ganglion. So this ganglion is connected by these intersympathetic ganglionic fibers. Okay, so through these fibers only the pain impulse is taken to the brain. Through these fibers only the pain impulse is taken. Thoracic cardiac branch of the sympathetic plexus. This branch is supplying the trachea and the bronchus. Okay, likewise this branch is supplying the splanchnic plexus. They are forming the splanchnic plexus and it is supplying the intestine like liver, gallbladder, spleen and the foregut. Okay, so this is called as a splanchnic plexus, and this plexus is called a lesser thoracic splanchnic plexus. This is called as a lesser thoracic splanchnic plexus, and this is a, okay. So all these plexus are innervating the visceral organs. All these plexus are innervating the visceral organs, in liver and all. Okay. Likewise, even for the parasympathetic nerve, if you see, this ciliary ganglion is formed from the yes, this is a ciliary ganglion. This is a ciliary ganglion just in the posterior aspect of the eyeball, just in the posterior aspect of the eyeball, that is formed from the third cranial nerve, that is the oculomotor nerve. But in the posterior aspect of this bone, you have the pterygopalatine ganglion. Actually, this pterygopalatine ganglion is said to be the largest ganglion in the body. Okay, to be the largest ganglion in the body, which is derived from the facial nerve, which is formed from the facial nerve. This is called as a pterygopalatine ganglion, one of the largest ganglion in the body. This is just present in the posterior aspect of this maxilla bone. It is present in the posterior aspect of this maxilla bone. Okay, so this is how The balance between the sympathetic and parasympathetic nerve is functioning. So when parasympathetic nerve is increasing, heart rate will reduce. Then the sympathetic nerve will stimulate and make the heart to work in a balance. Make the heart to work in a balance. Okay. So these are all the basic things you have to understand between the parasympathetic and sympathetic nervous system. So ultimately, the whole autonomic nervous system is controlled by a small piece in the brain, that is the hypothalamus. Okay, that's the hypothalamus. You have studied in the central nervous system. The complete autonomic nervous system is regulated by the hypothalamus. Okay, so well, this is what you have to learn about this peripheral nervous system, and I have given you the basic things. And when I teach about this gross anatomy, I will teach you individual nerve, further subdivisions, sensory branches, motor branches, muscle relationship, the tracts, okay, the route where the nerve is passing. So hopefully I will try to work out on those videos.